Hey everyone, this is Mr. Ting, and this is the first video in my series of how to conduct an EEI. In this series, I'm going to guide you through all the main things to consider when planning, carrying out, and then writing up an experiment. But do note that this is specific to a high school investigation and one in Queensland, Australia, to be even more precise. Also, I am a biology teacher, so most of my examples will be from biology. Therefore, don't take this as, the ultimate definitive guide to investigations. Although I will try my best to give tips that apply broadly. Also, if I'm your actual teacher and I've asked you to watch this video, well, you don't really have a choice. Okay, let's get into it. Well, choosing an investigation. For starters, what even is an investigation? Well, what is science, right? What is life? Science is all about, doing science. It's all about the scientific method. And the scientific method consists of this. We generally start with making observations. From that, we come up with a question. We predict, we make a hypothesis, and then we test that prediction, and finally make a conclusion. After that, the cycle can actually repeat itself, because that can be a new observation which continues to go into more testing. But as you can see, choosing an investigation will start with your observations. What are you actually observing? So, what does observing look like? Here's a multiple choice question for you. A, does it look like daydreaming? Does it look like seeing what's out there? Does it look like research and reading? Does it look like looking for a problem to solve? Which one? And the answer, of course, is, yeah, I tricked you. It's all of the above. Observing is just, it's looking around, it's doing all of these things. I know for the most part, it might feel like a lot of research and reading. And yes, that's true. You're going to do lots of that. But you're really just thinking. You're looking at things to be solved, seeing what's out there. A lot of thinking. And really, to me, it all boils down to asking a good question. Once you've made those observations and you've seen things, you just want to ask a really good question. This question will then determine the path of this entire investigation. What is a good question, though? Well, for starters, it's got to be something that's interesting. Something that's, I guess, new. Is this an area in science that we don't yet know? Like, we might know things about this topic, but is this some specific thing that we don't yet know? That makes a question an interesting question. Also, is this question going to be a useful question? Will finding this out actually help anyone? Not just because it's interesting or like, oh, I was curious and now I know. Like, is it actually beneficial? Is it something worth writing about? And lastly, in high school at least, we have to ask the question, is this question realistic? Like, can it actually be done with the time and resources that you have? If your question can fulfill all of these things, confidently you can answer it, it's probably a good question. And then we can move on to the next thing, which is that once you've got your question, you then need a hypothesis. Now, this is a bit of a confusing thing to many students because it's like, well, you've already got your question, you've got your aim. Why do you need to predict? Like, you just do it. And it's true. A lot of students actually often will carry out an entire experiment. They'll even write the report, and then right at the very end, they'll kind of like, oh, that's right, I need a hypothesis. And then they'll just like make something up. Because to them, the hypothesis is, just an educated guess, right? It's just like, oh yeah, things gonna happen. It's far more than that. I mean, yes, I guess it's an educated guess because you don't know what's gonna happen. But really, you could say the wrong hypothesis because it may not have been educated. Like, it can't just be a complete wild guess. It needs to be based in research. It needs to be like a really good prediction. Having a clear hypothesis at the start, I cannot say how important it is. You have to start with a hypothesis even before day one of testing, because the hypothesis determines how you design the entire experiment. It determines what you control, what you eliminate, how you even read the data. It's so important. Now, what does a good hypothesis look like? Well, one, a good hypothesis has to be testable. So that means it's got to be something that you can actually if it's true, you should be able to measure something. A good hypothesis should also be falsifiable. That's kind of the opposite of testable. It should be something where if it was false, I should be able to see this. Now, let me give you an example, all right? I'll give you a couple of hypotheses. So, here's one hypothesis. Every Tuesday, there's always a mosquito in my room. Is that a testable hypothesis? Well, I mean, sort of. I mean, you could look at a security camera, because I have security cameras in my room. Yeah, that's a total normal thing. Is it falsifiable? Well, it's not actually falsifiable. I can't actually prove that it's false, because if you didn't see one on the camera, maybe the camera just didn't pick it up. I mean, how can you 100% prove that there wasn't a mosquito in the room on Tuesday? Right? It's not falsifiable, which actually makes this not a good hypothesis. On the other hand, if you said every Tuesday there are no mosquitoes in my room, is this testable? Well, I mean, same thing. I guess look at the camera and stuff. Is this falsifiable? Well, in this case, there it is, because all you need to do is spot one mosquito in my room on a Tuesday. This is a weird example, but stay with me. All you have to do is spot one mosquito in my room on a Tuesday, and you have falsified it. You've shown this hypothesis to be false. That's not supported anymore. And we generally find hypotheses like the second one a little bit better. Well, I guess you could say they're a lot more like testable. We call hypotheses like these a null hypothesis. And the null hypothesis is basically a statement or a position that there is, it's the default position that there is no relationship between two variables. And a lot of science is really all about trying to reject or disprove the null hypothesis. And if you can prove that the null hypothesis is false, then you've actually then showed that there is a relationship. Now, this is kind of a little bit beyond high school science. I thought I'd just throw that in there. If you want to really get into, coming up with a good hypothesis and talking about it in good scientific terms, check out what a null hypothesis is and find out a bit more about it. Okay, let's give you an example now. So let's start with an observation, right? My observation is that mozzies seem to really like my sister, and they also seem to really like my daughter. Like, they, if we're out, I don't know, in the bush or something, they are the two who always get bitten by mosquitoes. I don't get bitten by mosquitoes as much. Well, definitely when I'm with them. It just looks like they kind of prefer them. Now, research, and I did research this, research seems to suggest that mosquitoes are actually attracted to specific chemicals, and there are different types of chemicals that people release from their body. So the question is, might genetics influence your attractiveness to mosquitoes? Right? Like, could there be something in the genes where, like, somehow in my family line, I'm not sure why it skipped me, but like both my sister and my daughter are like really attractive to mosquitoes. What a great question. Is it though? Is it a good question? Well, let's look at those three criteria. Is this interesting? Is this something that hasn't been tested before? Well, I kind of did a bit of looking around, and from what I could see, not really. And we have done mosquito studies, by the way. I mean, yeah, in case you think that I'm kind of like making this thing up, people do mozzie studies. This picture actually makes me want to vomit. So, yep. Yeah, it is a thing. So it is interesting. Is it useful? Well, definitely. I mean, according to the WHO, the mosquito is the world's greatest disease-carrying insect, and it's responsible for, we think, like 1 million deaths every year. 1 million deaths because of disease carried by mosquitoes. Crazy. It's definitely useful. I mean, knowing what causes mosquitoes to be attracted to people could actually be something that we can then use to our advantage and stop mosquitoes from, biting humans. Is it realistic to study this? Okay, to be honest, at a high school level, probably not. This is stuff that I'd probably want, like, university level equipment to study. But if I did have access to that, then yes, it would be realistic. So it passes all that stuff. Oh, gross, go away. All right, so based on that, what might a good hypothesis be? Well, here's one hypothesis. It's that people who are attractive to mosquitoes are more likely to have a child who is the same. Right? Because if it was genetic, then, it kind of passed down. Now, let's see if it passes the two criteria of a good hypothesis. Is it testable? Well, yes. I mean, there are actually quite sophisticated tests that look at, like, mosquitoes' preferences. So you can actually rate someone on, like, their attractiveness to mosquitoes. So yes, I can actually test it. And it's also, I can just find, parent and child pairs to come in and then, like, test them together. So it's not impossible. It definitely is testable. And secondly, is this hypothesis falsifiable? Well, it kind of is. And I mean, so not to go into too much detail with the null hypothesis again, but I could actually disprove the null, which is that there isn't any relationship. And if I find any relationship at all, using any mathematical or statistical analysis, that shows that there is a relationship. So this is falsifiable as well. What's the next step? Well, design the experiment. But those are the steps that you have to take at the start. You need to start with observation. You start with asking a really good question that fulfills those three criteria, and then coming up with a really good hypothesis that's both testable and falsifiable. Once you've done that, and only once you've done that, you've done all your research already, then you can start designing your experiment. Cool, hope that helped. This will be continued in part 2 when we look at the testing phase of an EEI. See ya.